Yes, dear learner, in last video I explained you working of moving coil galvanometer and I drew one diagram in which coil was suspended in a radial magnetic field. Here I have drawn two diagrams, one from NCERT. Actually in board exam, our paper setters and person who give the solution expect this diagram from student, but this diagram clearly does not explain the meaning of radial field and suspension type. Now here it is pivoted type galvanometer. Here this is the coil having maintained and inside the core concave shape. These are two springs and two terminals are there. So when we pass current through this, we connect across battery, current pass through this and coil get deflected. And that coil produce twist in these springs which provides restoring torque, and the whole thing is there as such in the last video on galvanometer. This diagram same. While drawing this diagram, please take care. This is also showing the radial field. Actually the field line corresponding to this is should be there. Corresponding to this it should be there. Corresponding to this field line it should be there. And so on. Corresponding to this is there. So this is the, I have told there is rectangular loop which is suspended vertically. So plane of loop, this is shown here plane of loop. So when current is passed through this coil, it deflects. I told you okay, here torque equal to NB IA sin theta, sin 90 रहता है. Actually that sin theta here is the angle between magnetic field and normal to the plane of loop, means angle between magnetic field and band diagonal. Okay, in one I explained ρ equal to m cross b. Here m equal to man diagonal of loop. So when it rotates this way, then these field lines become parallel to the plane of loop, and also on. So in galvanometer we use radial field, and I told you radial field is that in which plane of loop always remain parallel to magnetic field. This question is generally asked in different exams. And this soft iron core not only help in obtaining the radial field, it also increase the strength of it because it attracts the field lines. Actually these field lines should have gone like this, but they are concentrated in this and the coil remain in strong magnetic field. So radial field. I told you sensitivity. Actually here I am going to tell you the diagram because I told you if someone asks purity type, the diagram which I drawn in last video was suspended type galvanometer. It is purity type. The coil is pivoted at one point here and rotate. The same thing is this. So these two diagrams you can draw from different books and practice this, because sometime only they ask draw the diagram, well level diagram of galvanometer only. So there is nothing a diagram, and in class 12 CBSE board exam generally 15 or 16 marks question are of diagrams. Actually board purpose is to pass maximum. Competitive exam, entrance test exam aim is to fail maximum. So for board exam you have to prepare the questions. Diagrams sometimes they give the question from diagram also, but they are very rare. But anyhow we should understand. So I hope you have got these two diagrams. This is given in an NCERT book. And remember the galvanometer, some people are confused. Galvanometer is that which detects the presence of current. Yes, it detects, but we can make it, we can use it to measure the current as well as potential difference. Yesterday I told you the current sensitivity and voltage sensitivity. So in one I told you current sensitivity. I am repeating again because this topic is important for you. Current sensitivity I wrote there K equal to MVA upon C. So how can you obtain maximum by increasing number of turns, having strong field, having large area and small c? What is the c? The c is the restoring torque per unit angle of twist of this spring. So, but therefore we use very light spring here, not very strong here. To have but generally magnetic field of also magnet remain fixed. Area has limitation because of size. We can't go beyond a certain area. So generally we increase sensitivity by increasing number of turns. And then voltage sensitivity kV. I told you kV means I don't write here I. It is understood it is current sensitivity. This is voltage sensitivity part and VA upon CR. CR are the resistance of coil. And hence kV equal to K upon R. But this is K. Sorry, this is K only. So current sensitivity divided by resistance gives you voltage sensitivity. So generally, if we increase current sensitivity by increasing the number of turns, say we make it twice. Sensitivity we increase by double. So generally we make number of turns double, and when we increase number of double, the length of wire will increase, resistance proportional to length. So resistance may also become n times. If this increase n times, this increase n times resistance. So voltage sensitivity does not increase. It may decrease sometime, because resistance may be more than twice this resistance. I will tell you the question here. But remember, this relation is not written anywhere. What is this? Voltage sensitivity. Voltage sensitivity is equal to current sensitivity. Current sensitivity divided by resistance of coil. Resistance of coil. Dear student, this is very important topic. Just to understand working of galvanometer, to understand sensitivity, and also for achievement in the exam, because generally question is asked. So here is one question with me. I am telling you because my solution is totally different. So if we increase current sensitivity by any number of turns, then voltage sensitivity generally we say does not increase but may decrease. अब here a question with me. A moving coil galvanometer has N equal to 24. 24 turn area. Area of coil A equal to 2 into 10 to the power minus 4 meter square 3 minus 3 meter square, and B equal to 0.20 Tesla. Resistance R equal to 14 ohm. Suggest a simple way of increase the current sensitivity. So you are asked here how current suggest a simple way of increasing the current sensitivity of galvanometer by 25%. Now they say when we increase current sensitivity, delta K upon K have 25%. Resistance R dash becomes 21 ohm. Then how the voltage sensitivity be affected? So first of all, current sensitivity will increase by 25%. So simple way is to increase the number of turn. Simple यहाँ लिखेंगे आप simple way to increase the current sensitivity is by increasing the number of turns of the coil of galvanometer. At present it has 24 turns, area this, B this. So very simple, we know K is equal to MBA upon C. So let to increase K by 25%, we use endless turns. So in that case, what will be sensitivity? This is first equation. So K plus 25% of K is equal to into K. 25% ऐड होना है, इंक्रीज करना है इसमें, is equal to n dash B upon A, n dash B A upon C. It will be 1.25 K is equal to n dash B A upon C. Equation 2. Dividing 1 by 2. Dividing equation. This is the simplest method. No book has given such simple method, please. So dividing 1 by 2, we get 1.25 equal to n dash upon n. And now you are given n is 24. So n dash is equal to 1.25 into n is 24. Let me write here first. Or 1.25 into 24. You multiply it, 24 5 120 carry 12, 48 or 12, 60, 6 or 30. So now number of turns should be 30. So means we have to increase 6 turns more. If it originally it had 24, then to increase current sensitivity by 25%, we should have total number of turns 30. This is the simplest method, dear students. Please make sure of your arithmetic skills. Improve that. Percentage are determined only of the initial value. Now here he says that how the resistive voltage can be affected. Very simple. Original resistance 14 ohm. So KB is equal to, in fact, K by R है. K by R. So let it becomes KB plus delta KB. Or you can say let it be KB dash mu. So that will be, because it has increased by 25%. 25% of K upon R dash the new resistance. Or it is equal to 1.25 K upon R. This K by R is equal to KB. Sorry, K by R, sorry. K upon R dash. So if we divide this KB dash upon KB, what you will get? This K cancel 1.25 upon R dash into R. So 1.25 into R 14. 14 and it is 21. 7 2 ya 7 3 ya. K dash B. KB dash now. It is 2 by 3. 2 5 are 10. 5 and 2 upon 3 of KB. So it remains how much? 0.8, or if you try it like this, 250 upon 300 KB means K dash B is equal to 5 upon 6 KB dash. So new sensitivity will be 5 upon 6 of original. It means it has decreased. It has decreased. So this way you can try some other questions based on sensitivity, but remember this relation. If you forget this relation and remember K is equal to, again I am writing, and B A upon C, and voltage sensitivity, and B A upon CR. That is why it is K upon R. This thing is K. But so they give different questions based on this. I hope you have got my point. Yesterday there was a comment from someone that sound was not clear. Actually, my room was disturbed. I tried to minimize that disturbance because in small rooms, echo of sound create trouble, and acoustic of sound has to maintain. So if you get again sound not clear, please tell me and give your remark about how do you like the question, solution, etc. And I request again, if you feel that video is good, then like it and share it with your friends and ask them to subscribe my YouTube channel. Thank you.